Okay, Assalamualaikum and good afternoon, guys. Today, this is a video lecture for Chapter 1, Adaptive Controls. Okay, so here is the block diagram of the distribution of the adaptive controls. It has a control law and parameter estimation. The indirect adaptive control scheme offer a large variety of combination of control law and a parameter estimation techniques. So to better understand how this indirect adaptive control scheme works, it is useful to consider in more detail the parameter estimation of the plant models. So in a simulation, when we are going to simulate a models, there are many instances when we do not have the value of the parameter of the met models. So we doesn't know the parameter of the models. So the role of the parameter estimations is paramount in carry out the simulation studies. So in this lecture, we will be looking at how we can estimate this parameter by using parameter estimations. So mathematical model are the basics of the simulator, and the theoretical analysis of the dynamic system as a control system. So and the model can be in form of differential equations. Okay, the models can be in form of differential equations, or it can be developed by physical principles. Or we can use or we can find the transfer function by using system identification to find the transfer function, and we call it as the black box system. So for black box systems, we only have the data for the input signals and the data for the output signal. We doesn't have any knowledge about the transfer functions or the models that represent the signal. So this is the black box systems. Okay. So parameter estimations are used to determine the value of coefficients of the transfer functions. Okay, I already mentioned it before. So the objective of the parameter estimation is to provide the best prediction behavior of the closed loop system for given values of the controller parameter, and the need of the parameter estimation is for the system that is time varying, where the tracking of the variation is needed, and the system model that difficult to obtain. So that's the need of the parameter estimations. Okay, so here is the block diagram of the parameter estimations systems. We can try to estimate such parameter from the measurement taken during experiment on the system. So we have the data from the input signal and the output signal. We try to estimate the transfer functions of try to estimate the parameter of the transfer functions. So we have a physical systems. Here is physical systems, and on this physical system, certain input signals is given, okay, and we get a certain output signals. Now, with the help of the input signals and output signal, we can have the parameter estimation for the mathematical models with the help of the input signal and output signals. And from here, we can find out the model parameter, that is the parameter vector can be identified. So in this lecture, we're going to see how we can identify through the estimator for mathematical models by giving the input and output signals. Okay. So here we will discuss the popular least square methods, or in short we call as LS method, for parameter estimations. And so how does the least square method look like? So I have to write down some things. So we can assume the standard regression model as y equal to phi1 theta 1 plus phi1 theta 2 plus phi n theta n. Okay, so we can segregate the phi and theta. So here I can write down this phi separately. So y is equal to phi1 plus phi2 plus so on plus phi n times theta 1, theta 2, theta n. So these the standard regression models of least square error. Standard regressions models of least square method. Okay. So here we know the value of phi. Okay, we know the value of phi. And we also know the value of y. Y is observed variables. Y is observed variables. And we know the value of y. Y is known. Okay. And theta here is unknown parameter. Unknown parameter vector. And we will use the least square method to estimate what is the value of theta. Okay, so we use least square method to estimate the value of theta. Okay, so this can be represented in short by phi. Y is equal to phi, and this can be represented by theta. Since the regression models is linear, so we are able to sum up and using the superposition theorems. So in short, we can write these equations as this. So y equal to phi theta. Okay, now assume that we have m corresponding value. So we have m corresponding value. Okay, so we can write down the following m equation according to the models. So y1 equal to phi11 theta 1 plus phi1 2 theta 2 plus phi 1 n theta n, or in short we can write down as phi 1 theta. Okay, so we have m corresponding value. So until ym is equal to phi m1 theta 1 plus phi m2 theta 2 plus phi mn theta n, and in short we can write down as phi m theta. So theta is the unknown to me and I am interested to find value, and I know the value of theta is unknown. I want to find this value, and y and phi is known. Okay, so this how we can write down the m expressions when we have m corresponding value. Okay, and we also can express it in metric form. Okay, so in metric forms we can get y1 ym equal to phi 11 phi 1m phi 1n phi mn. Okay, so times theta vector theta 1 until theta n, okay, equal to phi 1 phi m times theta 1 theta n. Okay, so that can be written down in compact forms as, so this can be write down in compact forms as y equal to phi theta. So this equation represent this matrix. Okay, so we can calculate or estimate the value of the unknown theta using least square methods. In the least square problem, what we do is that we define the error vector, where the error vector is equal to, in least square method problems, what we do is we define the error vector. Okay, so where error vector will be basically y minus phi theta. So we can arrange the error vector. So error vector, okay, E equal to E1, E2, so on, and EM equal to y1 minus phi 1 theta, y2 minus phi 2 theta, until ym minus phi m theta. Okay, or in short we can write down as E equal to y minus phi theta. Okay, The problem is to calculate a value or estimate of the unknown parameter theta, parameter vector theta, so that the following quadratic creation function v theta is minimized. Sorry. So here is the quadratic criterion functions. Okay. So what we can say is that we try to find the value of theta, okay, such that this summation of the square of the error is actually minimized. Okay, the equations of quadratic criterion function v theta is equal to e1 squared plus e2 squared plus em squared. So what we try to do is that we try to find the value of theta such that these summations of square of the error is actually minimized. So what this square method is all about. We try to find the value of theta, so the square of the error is minimized. Okay. So I write down it again. The function we try to minimize, v theta is equal to e1 squared plus e2 squared plus em squared. Okay. So in compact form, we can write it down as v theta equal to e transpose e. Okay. So in short, so E transpose, error vector transpose multiply by with the error vector. Or in short, this can be write down, okay, in short, so in more details, it can be write down as v theta equal to y minus phi theta t times y minus phi theta. Okay, so we multiply transpose inside, so we get y transpose minus phi transpose theta transpose times y minus phi theta. Okay, so we expand the bracket, we will get y transpose times y minus y transpose phi theta. Okay, so another one minus y times phi transpose theta transpose, another one times minus plus phi transpose theta transpose phi theta. Okay, so from here I write down it again. Okay, v theta is equal to y transpose y minus y transpose phi theta minus y theta transpose phi transpose theta transpose plus phi theta phi transpose theta transpose phi theta. Okay, so now we will differentiate this dv theta with respects to the theta and make that equations equal to 0. So from here, dv theta over d theta equal to mana ni 2 phi theta minus 2 phi theta y equal to 0. Or if we substitute the equation of error, we know error is equal to y minus phi theta. Okay, E1 equal to y1 minus phi 1 theta. Okay, so substitute in the equation, v theta equal to E1 squared plus E2 squared plus so on. So v theta equal to y1 minus phi 1 theta squared plus y2 minus phi 2 theta squared, and differentiate with respect to theta. So dv theta over d theta equal to 2 y1 minus phi 1 theta minus phi 1 right. Tu tak I buat ni. Okay, so plus 2 y2 minus phi 2 theta minus phi 2 plus so on. Okay, so by simplify the equations, okay, you will get dv theta over d theta equal to minus 2 y1 phi 1 plus 2 y2 phi 1 2 phi 1 theta. Okay, so before we have calculate the equations, the first derivations of the dv over dt, 2 phi transpose phi theta minus 2 phi transpose y. Okay, so it's dv theta d theta equal to minus 2 phi transpose y plus 2 phi transpose phi theta. Okay, actually equation 1 and equation 2 is same. Okay, so it's the same, right? So here is y transpose y1 y phi transpose phi minus 2 minus 2 2 2 phi 1 phi 1 phi transpose theta theta. So equation 2 is equal to 0. 2 is equal to 0. So we will get 2 phi transpose phi theta minus 2 phi transpose y equal to 0. So 2 phi transpose phi theta equal to 2 phi transpose y. And we want to find the value of theta. What is the value of theta? Okay, so I multiply both right and left side of the equations with the inverse of these equations. Okay, so theta phi transpose theta, so inverse is phi transpose ni phi transpose multiply with phi. So transpose is theta transpose phi transpose multiply phi inverse. Okay, so I multiply the inverse of the equation, both side of equations, left and right. So we will get phi transpose phi minus 1 times phi transpose phi theta equal to phi transpose phi minus 1 phi transpose y. Okay, so we already eliminate 2. Okay, so here is equal to 1. Therefore theta is equal to phi transpose theta phi transpose phi minus 1 phi transpose y. Okay, now so this is the objective of the parameter estimation. We will try to find the value of theta. We know the value of y and phi. So after all the derivations, we already get, if you want to find or estimate the value of theta using least square error, we have to use the equations or the formula of phi theta phi minus 1 phi transpose y. So these the equations of theta, finding or estimate the value of theta. Okay, now I will go more deeper or show you an examples on how to use the equations. Okay, it seems like complicated, but actually what I try to do is that I try to show you how we get this equation. We don't simply use the equations. So most probably we will get, we will have two known parameter and we try to find one unknown parameter in one its experiments. Okay, so I think that's all for today's video lecture. I think it's quite okay. You can ask me if you don't understand any equations or derivations. Okay guys, so I think that's all.